Good afternoon. Welcome to the sixth and final presentation for the Edelman competition. My name is Michael Trick, and I am chair of the judging committee. Just a few announcements before we have our final presentation. This session is being recorded at the back, so please turn off your cell phones so we don't listen to that on the recording. And there's no reason to record or live stream this because we'll have a nice professional recording at the end of this. Because it is being recorded, we'd appreciate it if you do not move around unnecessarily. If you do leave, you won't be allowed back in, but this is being simulcast in another room somewhere around the corner. After the presentation, there'll be a 10-minute question and answer period with the questions coming from the judging panel. It's my pleasure to announce the sixth Edelman finalist, U.S. Army Sandia National Labs.
Good afternoon. I'm Brigadier General David Bassett. As the Army's Program Executive Officer for Ground Combat Systems, it's my privilege today to introduce the Capability Portfolio Analysis Tool, or CPAT, the Army, and we think, the Department of Defense's preeminent analysis tool for acquisition investment. CPAT is an operations research project within the Army that has transformed the way we think about acquisition and our long-range planning strategies. Karl von Clausewitz, a Prussian general and military theorist, said in the 19th century that war is an extension of politics. And as the nation's primary land force, the U.S. Army executes the political will of our nation's leaders. We influence our adversaries sometimes merely by our presence, sometimes coercing action through strength, or, when necessary, compelling and defeating our enemies. The Army's mission is simple and straightforward. More than 1 million men and women, volunteers in uniform, that fight and win our nation's wars whenever, wherever called upon. Our new operating concept captures it quite succinctly: win in a complex world. Even as the Army is moving forward to reduce its footprint in Afghanistan, the Army is deployed to more places now than at any time in the last decade. From reassuring our allies in the Ukraine to the recent partnership activities in the Baltics, the Army's on point. It was the Army that was charged with responding to the Ebola crisis in Africa. The Army has redeployed thousands of troops to train our Iraqi allies as they move to counter ISIS. In this complex global environment, the Army has been called upon repeatedly to answer our nation's call. To equip an institution as diverse and large as the U.S. Army, you need a trained team of professionals dedicated to the art and science of acquisition, engineering, finance, contracting, logistics, and yes, operations research and systems analysis. The Acquisition Corps designs, builds, and sustains all of the equipment for our million-strong force, and I am personally responsible for giving our soldiers the best ground combat systems available. We'd like to say that we give our troops the best equipment that money can buy, and while that is certainly our goal, the reality is that the Army's budget, like any large institution's budget, is limited, and our leadership is forced to make difficult trade-offs between personnel costs, investments in training and readiness, modernization, acquisition, and preparing for the future with investments in science and technology. After every major conflict, the Army has been reduced in size from peak wartime levels, and this time will be absolutely no exception. The Army has already begun to shrink, and over the next 3 years, the active duty Army will be reduced by 80,000 soldiers. And even as budget cuts have forced reductions in the size of the force, the reductions to funding available for research, development, and acquisition have become even more drastic. In FY16, the Army will have 38% less funds available for equipment modernization than expected only a few years ago. When faced with these reductions, we found ourselves in a very difficult position. We were no longer limited by availability of technology to support our soldiers. Technology was there, from better optics to better networks, better weapons and better munitions. We were limited by budget. And opinions on the best way to spend that budget were the single thing for which there seemed to be an unlimited supply. Making decisions about which ground combat systems to invest in is an inherently complex undertaking. It has to take in a range of factors. The decisions must fit within the portfolio's budget, not just for a single year, but for across the entire 7-year planning period. It has to reflect program schedules that meet key industrial base limits and manufacturing executability. More importantly, it has to quantify military utility, something that previously was almost entirely subjective and could depend just on the personalities of the generals in the room when the decision was made. These are literally billion-dollar decisions that previously depended on the collective knowledge and opinion of a very diverse set of stakeholders, but were not framed by analytical rigor. It became clear that we needed better analytical tools to help us to prioritize what had become limited modernization resources. And CPAT was our answer to that challenge. It's the innovative methodology that's needed to support the Army's mission in maintaining strategic combat power. CPAT is built on sound operations research methods and supported by authoritative data. It's informing billions of dollars in investment decisions for the next generation of ground combat systems. In the summer of 2013, the Army was faced with a set of bad choices for combat vehicles, with the reduction in funding due to sequestration. And CPAT provided the analysis to support a very difficult decision. The Army's number one priority ground combat system modernization program at the time was the Ground Combat Vehicle, or the GCV. It was intended to replace the Bradley Fighting Vehicle, and with the technology and requirements given to the program manager, it was clear that it would consume a significant portion of the portfolio's budget. CPAT allowed the Army to consider dozens of different investment scenarios, and ultimately, it gave the Army the confidence to halt the development of the GCV program, harvesting more than $5 billion out of the portfolio and spreading the remaining funding across the portfolio to incrementally upgrade current platforms like Abrams, Bradley, and Stryker through engineering change proposal, or ECP upgrades, giving priority to replacing our oldest and least capable platforms with the Armored Multi-Purpose Vehicle, AMPV, and the M109A7 Paladin howitzer upgrade. Let's hear from Lieutenant General Williamson, my boss, the senior acquisition officer in the United States Army and the military deputy to the Assistant Secretary for Acquisition, Logistics, and Technology.
The U.S. military is facing one of the most challenging fiscal periods in its history. More than a decade of costly war in the Middle East has led to significant wear and tear on both military personnel and combat systems. The Army's fleet of combat vehicles is key to the success and protection of U.S. troops and includes a diverse array of systems, including the Abrams tank, the Bradley Fighting Vehicle, the Stryker family of wheeled systems, the self-propelled howitzer, and even the M113 personnel carrier, which dates back to the Vietnam era.
As the Principal Military Deputy to the Assistant Secretary of the Army for Acquisition, Logistics, and Technology, I monitor and direct command policy for technology and acquisition. The United States Army provides warfighters with the most mobile, lethal, and best protection equipment in the world. That mission requires detailed planning, coordination, and accurate predictions on the landscape of warfare and future budgets. Since the Budget Control Act of 2010, the Department of Defense has experienced steady budget reductions and portfolio management challenges due to unprecedented budgetary pressures, putting many important programs at risk. A tremendous strain has been placed on the Department of the Army's ability to develop and deliver new equipment to the warfighter while maintaining a strategic advantage over our enemies. The proposed cuts challenge the Army to analytically examine our vehicle modernization and maintenance strategy, resulting in tough choices on key Army programs. Analytics are necessary to determine the optimal time to introduce new equipment into our schedule while maintaining and modernizing our existing portfolio to avoid wasteful use of taxpayer dollars.
Beyond the logistical and budgetary problems, the Army also needed to contend with new threats and emerging enemies. At a time when modernization and maintenance investment was badly needed, the economic and political environment in the U.S. led to the opposite, a dramatic reduction in military budgets. As a result, acquisition decisions required advanced portfolio analytics more than ever.
Since assuming office as the Army's acquisition executive and Assistant Secretary of the Army for Acquisition, Logistics, and Technology, the Honorable Heidi Shoe has pushed for analytics to underpin each new program that she will endorse. Previous analytical methods fell short of providing Army leadership with the holistic impacts of investment decisions within a portfolio. The need for reliable and defendable operations research and quantifiable analytics was evident.
To address these challenges, the U.S. Army partnered with scientists at Sandia National Laboratories to develop the Capability Portfolio Analysis Tool, CPAT, a decision support tool that employs sophisticated, mathematically rigorous techniques from operations research to greatly enhance the ability of senior military leadership to make investment decisions.
The Capability Portfolio Analysis Tool, or CPAT, is a powerful fleet modernization management analysis tool that optimizes investment and fielding decisions, allowing maximum fleet performance under cost, schedule, and programmatic constraint. It is capable of solving highly complex fleet modernization optimization problems spanning many mission areas and modernization programs over several decades.
Under development since 2009 and first applied as an analytical capability in 2012, CPAT has already identified $5 billion in cost savings to the military, while also identifying an investment plan that leads to 30% greater combat performance per dollar. CPAT has been adopted by the most senior leaders within the Army and is changing the acquisition culture within the Army and becoming a standard by which portfolio management is conducted.
Before CPAT, traditional Army acquisition processes lacked all-encompassing, analytics-driven methodologies for optimally prioritizing available funds. CPAT provides guidance for multi-billion-dollar Army acquisition decisions through unusually challenging fiscal environments, providing maximal future capability and protection to our troops.
You can tell from that video that when we talk about ground combat systems, we're talking about the most protected, mobile, and lethal systems in the Army's inventory. You deploy these systems to close with and destroy the enemy. So it's that much more important that we get our investment strategy right. The ground combat systems portfolio spans more than 22,000 vehicles and somewhere in the neighborhood of $2 to $4 billion annually. The value of that equipment in this portfolio is in excess of $100 billion. So even on the high end of that investment range, resources are not unlimited. And we must plan on keeping our vehicles for more than 20 years each. Our resources must cover every phase of technology development, vehicle design and manufacturing, modernization of existing vehicles, sustainment, and ultimately divestment as systems are retired from our fleets. I talked before about the Army's decision to halt the ground combat vehicle program, and the strategy depicted on this chart shows the results of that CPAT analysis and decision making. Although the Army clearly understands the need to replace the Bradley fighting vehicle, when we were faced with the decision between funding GCV and investing across the rest of the fleet, the data was clear. The warfighting military utility of that vehicle was not greater than what could be generated by investing across our current fleet and by taking a low-cost, pragmatic approach to the Armored Multi-Purpose Vehicle program. This strategy also left us with enough resources to invest in the future, with S&T efforts focused on active protection systems, advanced lightweight armor and materials, advanced designs for future infantry fighting vehicles. These technologies become the seed corn for future advancements. Now I'd like to introduce Mr. Scott Davis. He's my predecessor in PEO ground combat systems, and he was instrumental in the development of the CPAT tool and is currently serving as the senior executive in charge of the Army's Program Executive Office for Combat Support and Service Support. Scott.
Thank you, General Bassett. I'm going to talk about the Army's PEO role a little bit. Across the Army, there are 12 PEOs, each overseeing multiple commodity-based product lines to field Army equipment. More challenging than what most industry program managers might experience, Army PMs must manage many stakeholders with varying opinions on the best strategies for Army equipment acquisition. often without defensible analysis. Our PMs must balance the following things: competing pressures for constrained budgets, challenging user requirements, congressional constituencies, and many others, not to mention potentially unintended consequences. In the recent past, the problem isn't only that the budget is declining. It is perhaps more important that the overall predictability and timing of budgets has been challenged. Fiscal uncertainty demands responsive analytical tools that can aid in decision-making once the budgetary status is known. We found ourselves in a complex, increasingly complex world with an accelerating velocity of instability. We needed more precise, focused, and data-driven decision-making than ever before. It became apparent that the Army needed an analytically defensible and affordable modernization strategy that would unite and align our diverse stakeholders. We had to find a way to maximize the capability return on every investment dollar. Early portfolio analysis used fleet age as the primary trigger for modernization decisions, but it lacked a view of how upgrades of individual systems impacted the overall portfolio capability and how limited resources could best be allocated at the portfolio level. Portfolio reviews initiated by the Vice Chief of Staff of the Army reinforced the fact that the Army lacked the analytical underpinnings to develop and support an affordable long-range combat vehicle modernization strategy. Analytics needed to involve inputs from multiple stakeholders to unify the community behind a defensible plan. We needed a model that provides insights beyond the obvious and explores the trade space within the portfolio to ensure that we don't make a decision that creates a negative unintended consequences. I challenged my team to develop a comprehensive plan that would provide me the analytical underpinnings I needed to do the following: inform leaders on overall portfolio health in terms of baseline capability, explore alternatives that maximize fleet capability within bands of affordability constraints, understand the implications of applying external constraints, for example, political preferences and industrial base impacts. I would now like to introduce my project manager on CPAT, Mr. Shatil Edwards.
Thank you, Mr. Davis, and good afternoon. The analytic challenge of the task Mr. Davis charged me with required a diverse team, a team that consisted of the Army's research centers, the program offices, the soldiers and soldier representatives, the Department of Budget Office, and the Department of Energy. Once the team was assembled, I invested time in socializing the concept and framework of the CPAT process with key Army stakeholders. This was done to ensure we built a unified coalition that understood how CPAT could be used to develop a long-term strategy. Next, we needed to structure the problem. That structure was built on baselining the current state of the Army's combat vehicle fleet. From there, we built a continuum of alternatives for each mission role, projecting out each mission role. Further, we spent time in the early phases of the CPAT process conducting market research to understand the complexities of acquisition and the realities of manufacturing. The data gathering phase focused on the three tenets of acquisition: cost, schedule, and performance. The performance analysis was done in close collaboration with the user communities and aligning the key stakeholders. As you can imagine, the immense volume of data that was collected requires sophisticated optimization software to parse into cogent results. CPAT provides a robust output analysis set of graphs showing the results of the optimization that the team uses and modifies to develop the summary of briefings for senior leaders. The team carefully analyzes each course of action to highlight the direct and indirect implications to the portfolio. Finally, we provided a recommended course of action to leadership for their review. The key element to any data analysis modeling is data, the quality of the data, the believability of the data, and that is done through going through authoritative sources. In our business, we cannot guess. Sir Arthur Conan Doyle once said, "It is a capital mistake to theorize before one has data. Insensibly, one begins to twist facts to suit theories, instead of theories to suit facts. The program offices within the PEO are the authoritative sources on program cost data. We knew if dollars were going to be limited, the future it is imperative that we modeled our cost elements accurately. Thus, we relied on the cost teams within these offices to ensure we use realistic cost assumptions. We modeled the research and development and procurement cost of each new alternative. Additionally, we modeled the operation and sustainment cost for all alternatives. Modeling at this resolution allows decision makers to understand the full breadth of cost implications of each courses of action. The schedule data was also provided by the program offices. The schedule data elements we collected were detailed breakdowns of vehicle availability, production constraints, min and maximum rates, and PM-specific planning assumptions. The team coordinated with the Department of Budget to align the near and far-term budget planning so that we had the assumptions that we were properly modeling. The performance model utilized a multi-objective decision analysis approach to evaluate each alternative. What was once a subjective and ad hoc process, the CPAT team synthesized the data and quantified military utility. The steps we took in developing the value model were time-consuming, but critical to the success of CPAT. The value hierarchy and measures were derived through the decomposition of the requirements documents, and that resulted in the identification of 40-plus metrics to use in the evaluation per mission role. The value functions were developed by working closely with the users and experts from science and technology to develop representative value curves for each metric. Next, we developed a prioritization scheme that allowed the Army's user representatives to provide input as a priority of and importance to each metric to each mission role. We collected data on over 100 alternatives. The Army's Material Systems Analysis Activity, AMSA, conducted an in-depth quantifiable analysis of each alternative against each metric. The performance evaluation methodology provided a framework for evaluating the performance of a vehicle-specific role in the Armor Brigade Combat Team and Stryker Brigade Combat Team. After we completed the data analysis phase, we contracted with the Naval Postgraduate School to conduct a validation and verification of the model. Additionally, we coordinated with the Army TradeOffs Center to conduct a comparative analysis with CPAT results and the leading combat effectiveness models. The Analysis Center came back with a high correlation in the results. In completing the data gathering and analysis phase, we were left with an enormous volume of data. And following my process for ensuring we went to authoritative sources for data, I went to the best for optimization analysis, the Department of Energy, Sandia National Labs. Dr. Hummert and the Sandia team will provide some additional detail on the formulation and execution of CPAT.
Hello, I'm honored to speak to you on behalf of Sandia National Labs team responsible for the Capability Portfolio Analysis Tool, or CPAT as we call it. As a premier engineering lab, Sandia applies cutting-edge research to our nation's most challenging national security issues. Included in our mission is a long-standing tradition of cooperation between the Department of Energy and the Department of Defense. And there is no better example of this cooperation than the CPAT capability. Sandia scientists Craig Lawton and Matt Hoffman have led the lab's effort in establishing a successful partnership with the United States Army to develop a combination of software and methods to analyze countless what-if scenarios for the nation's top generals and senior executives. In today's financial environment, CPAT has helped the Army and DoD prioritize difficult investment decisions for future ground systems so that the current fleet could continue to be modernized. In all, CPAT identified $5 billion in acquisition investment savings, while still identifying improvements in combat performance through optimal investment strategies. The CPAT team is making a substantial impact on the Army's investment strategies. We are strongly committed to our ongoing partnership with the Department of Defense and will continue providing exceptional and innovative operations research capabilities to support difficult decisions in the decades to come.
I would like to now introduce Mr. Craig Lawton, my project manager from Sandia National Labs.
Thank you, Mr. Edwards. Good afternoon. I'm Craig Lawton, the project manager at Sandia National Labs for CPAT. I'm going to talk to you today about our modeling approach and formulation. So our role at Sandia was to develop a modeling approach that distills all of the complexity you've just heard about so that we could formulate a portfolio investment optimization model that allowed for decision support for major acquisition decisions. In addition, Sandia served as the developer of the software that contained the model and the primary analyst supporting the Army analysis around these acquisition decisions. So the value model that Mr. Edwards just described allows us to aggregate a complex set of data around mission roles and ground vehicle alternatives for those mission roles. This complex data set feeds a rich network of modernization paths for each mission role. Paths represent vehicle system upgrade alternatives that may be intermediary systems or final new vehicles that will be fielded. So the optimization chooses the best mission modernization path that maximizes performance within budget and schedule restrictions. The best modernization paths result in brigades of vehicle systems that are phased out and replaced by new systems, ultimately resulting in performance increases. Performance can be summed across all mission roles over time, and this is what the optimization maximizes. So I want to talk a little bit more about the complexity of this problem, as modeling in this approach required developing innovative approaches to mitigate this complexity. More than 40 business rules were modeled through an extensive set of constraints. We believe the expanse of these 40 business rules and the complexity of this constraint set is unprecedented in a MILP at this scale. So we refer to this constraint set as Omega, and I will talk about it a little bit more in the future. I'm not going to go into the mathematical details of the constraint set, but some examples of what it is representing include complex rules governing purchase, storage, and fielding, economies of scale, breakpoints, cost breakpoints, cascading modernization, vehicle program cost sharing, and production continuity and smoothing, to mention a couple. The development of a model of this complexity requires iterative reformulation and refinement for both technical accuracy and computational efficiency. We're on the edge of solvability with this MILP. This iterative process was not ad hoc, but governed through a thorough configuration management and testing system. So as I mentioned, the principal objective of the formulation is to maximize performance subject to the set Omega. But other considerations are important as well, such as optimizing schedule, budget, and cost. To handle this, we formulated a phased approach consisting of a series of objectives that are solved sequentially, allowing schedule and cost to be optimized while still maximizing performance. CPAT can often be used to identify truly optimal schedules, but often we were given schedule mandates embedded within courses of action that we were asked to evaluate, such as we must retire all M113 vehicles by 2025. I should point out that we are not given highly detailed schedules to evaluate, but rather high-level mandates that guide when certain investments must take place. So the first two phases of this phased approach basically ensure feasibility, that the schedule mandates that we are given will still be feasible within the budget allocations we have also been given. The third phase ensures that we still have minimal cost even when maximizing performance. So this phased approach proved essential when diagnosing model behavior and debugging the model. Notice that we are not solving 4 independent models separately, but we are feeding the results of one phase to a subsequent phase. We do this through a sophisticated warm starting procedure. So also, in certain courses of action, some mission roles are prioritized above others. So we employed a tiering construct that ensures that higher priority mission roles are funded before lower priority mission roles. We can have an arbitrary number of these tiers. So I want to talk a little bit about the architecture of the software that we developed. As I mentioned, Sandia was also the software developer. At its core, CPAT uses an industry standard solver, Cplex, we invested significant result and effort in developing visualization techniques and allowing us to perform comparative analysis involving multiple courses of action. Now I will hand it over to my colleague, Matt Hoffman, who is the CPAT project lead at Sandia, as well as the chief analyst.
Thank you. In order to assess different stakeholder ideas and the effects of external influences, such as budget reductions, an analysis typically involves running multiple copies of the model under different assumptions and constraints, and then comparing the results of those runs to generate insight. In the study shown here, performed in 2013, we ran the model under different potential budget reductions to understand when it becomes optimal to discontinue the Ground Combat Vehicle Program, or GCV. The modernization plans on the left, in blue, include GCV, while the plans in red on the right discontinue the program. Above 20% budget reduction, we see a phase transition where it is no longer optimal to invest in GCV. Each of these points is a fully defined multi-decade modernization plan that can be examined in detail using dozens of different results views. From the modernization schedule, showing which systems are fielded to the fleet when, to the yearly cost outlays, which allow us to examine acquisition costs and assess which years have the tightest budgets, to the performance contribution over time, which shows how different programs contribute to overall performance as they replace the status quo. Another way to look at a modernization plan is to compare the performance status quo in the first year to the end state in the last year, to get a sense of the overall strategy and the involvement of each program in this strategy. This also allows us to compare multiple courses of action on the same chart. In this study, the first course of action is an optimized version of the Army's existing plans at the time. The second is fully optimized by CPAT without any of the mandates placed on the first. Finally, the last two courses of action assess different ways of dealing with a 25% budget reduction in the first 4 years of the planning horizon. The Army's existing plan at the time did not include Stryker modernization, and thus relegated the Stryker upgrade program to the second priority tier, while instead prioritizing the Abrams ECP-1 and GCV programs. Unfortunately, these two programs compete for funding in some very tight budget years. This forces multiple programs to be decelerated significantly to stay within budget, and therefore prevents full modernization of the mission roles fulfilled by the Abrams, Bradley, and Stryker systems. We can see in the next column that CPAT does things differently to achieve greater performance. First, it chooses not to force a multi-program compromise in order to field both GCV and Abrams ECP-1. Rather, it forgoes Abrams modernization in favor of fully modernizing the Bradley mission roles to GCV and Bradley ECP-3. We also see that Stryker is fully modernized, providing significant capability improvement. This was a pivotal result in that from this point forward, the Army has fully prioritized Stryker in its modernization strategy. In the last two columns, we see how things change under a 25% budget reduction. First under an Army proposal, and then in an unrestricted CPAT optimization. In the Army concept, PIM and Abrams modernization are sacrificed in order to keep GCV. CPAT, however, chooses to discontinue GCV and instead preserve all other modernization programs and continue upgrading the Bradleys up through ECP-3. Not only is this concept affordable under a reduced budget, but it actually outperforms the original unaffordable modern Army plan for significantly less cost. There is one final point to note on this chart before moving on, which is that in all the plans evaluated, the AMPV program to replace the aging M113 is a fundamental element of the modernization strategy, which provides major capability improvement. I will now hand it back to Mr. Davis to discuss the impacts of the CPAT project within the Army.
From the two analyses that Matt mentioned and 9 other studies performed in 2013, several insights emerged that fundamentally shifted the Army's modernization strategy. The Stryker modernization became a priority within the Army. The analysis showed the Stryker modernization is highly desirable because it provides some of the largest capability improvements at a relatively low cost. Additionally, not only did CPAT confirm that the AMPV program should be a priority, it also showed that it was affordable and highly desirable to accelerate its fielding if future funding is available. CPAT also consistently favored investment in interim modernization options, which provides early performance gains to soldiers in years before more aggressive major programs could be executed. This and other insights headed off proposals to severely delay or cancel programs such as the Bradley ECP-2. Finally, under the deeper budget cuts that came to pass, CPAT provided critical insight into the difficult decision to redirect over $20 billion from the GCV program into maintaining the solvency of other modernization programs. Through these major programmatic insights and coordination across programs, CPAT demonstrated how the Army could achieve significantly better combat capability while maintaining affordability under reduced budgets. Ultimately, the CPAT plans, which formed the basis for the Army's new modernization strategy, saved $5 billion compared to the Army's previous strategy, and more importantly, bought 30% more capability improvement per dollar spent. CPAT has also prompted cultural changes in planning horizons and the rigor of Army modernization planning. CPAT enabled to focus on strategic capability investment planning and laid the groundwork for a PEO GCS modernization plan and prompted a larger distribution of CPAT. Given the close collaboration between various Army stakeholders, CPAT was a catalyst to align and unify the Army's future vision for combat vehicles. CPAT is regularly called upon by the Department of Army headquarters to support what-if drills, something that was previously done through only subject matter expert discussions. CPAT has added analytical rigor to the process. It has demonstrated the utility of performing investment planning over a long time horizon. This led to mandated changes in how PEOs perform portfolio analysis and instituted a policy dictating that each PEO perform long-range investment requirements analysis, and yes, another acronym, LIRA, over a 30-year time horizon. Now, as the PEO for combat support and combat service support, I have applied the CPAT process to a very large truck portfolio, a fleet larger than the roughly 200,000 trucks owned by the U.S. Postal Service, to inform modernization and fleet management issues that I face and the many complex challenges. New CPAT iterations have been executed for the PEO for Enterprise Information Systems, and they do our infrastructure, software, and computing systems, and are currently being done in my current capacity, focused in on tactical wheeled vehicles. The success of CPAT also spawned a new model, one that focuses on individual systems and their components that make up those systems, the whole system trade analysis tool. And this has leveraged the process and approach of CPAT and is currently being utilized on over 10 major programs to inform affordable capability trades within system designs. The CPAT process is well suited to almost any large problem where complex capability options are available across numerous systems, all within cost constraints. Through its use of proven operations research techniques and applied by competent ORSAs, CPAT has proven that analytics will drive the future strategies of the Army. I'd like to show a short statement from my boss, the Honorable Heidi Shoe, who is the Army's acquisition executive.
Hello, I'm Heidi Shoe, Assistant Secretary of the Army for Acquisition, Logistics, and Technology. Thank you for listening to my team's presentation on the important work from the Capability Portfolio Analysis Tool, or CPAT. As the Army's acquisition executive, it is my responsibility to make decisions on investments for over 600 Army programs. These are multi-billion-dollar decisions that directly affect our combat effectiveness. When budgets are significantly reduced, as we have seen over the past 4 years, these decisions become more complex. I rely on my teams to provide me with holistic and defendable options to make informed strategic decisions. CPAT has provided great insight into these challenges and has helped us achieve significant improvements and billions of dollars in cost avoidance. This team has developed an analytical framework that can be used by our entire acquisition community. With CPAT, Army leadership can now base investment decisions on rigorous portfolio analytics and provide the best capability to our soldiers while being responsible stewards of public funds. Thank you.
Thank you, Ms. Shoe. We're proud to be able to present this body of work to you all. I would like to thank Informs and the panel for taking the time to explore the great benefit CPAT has given the Army, and we'd be happy to take any questions you might have.
Thank you very much.